All right, thanks for tuning in today. Here we are about to start one of my favorite chapters. Today we're starting chapter 3. And of course, we better look at what this learning target is. What are we trying to accomplish this chapter? So if we take a look right here at the top of our notes, learning target number 2, I can know and apply properties of lines and angles. Okay, so we've already looked at some things with lines and some things with angles. We're really going to hone in and focus on the angles that we get when we have lines, particularly two lines crossed by a transversal, but we'll get to that in a little bit. So let's start with some vocab. Okay, skew lines. I may have mentioned this before, but I'm not really sure. So skew lines are lines that don't intersect. Okay. Now, there's got to be more to it than that, because we know that lines that don't intersect are usually called parallel. So what's the difference between parallel lines and skew lines? And I know we talked about the definition of parallel lines already this year. So why don't we just take a second here and go back and look up our definition of parallel lines. So I'm going to give you a couple seconds. Go ahead, pause the video, look up our definition of parallel lines. All right, hopefully you found it. And what did you find for that definition of parallel lines? Two lines are parallel if and only if they are in the same plane and do not intersect. So that same plane part of it, okay, is what differentiates parallel lines from skew lines. Skew lines are going to be lines that don't intersect but are not in the same plane. They are not coplanar. I'm going to go to the keyboard here to type up our definition. Definition of skew lines would be two lines are skew if and only if they do not intersect and are not in the same plane. So what would that look like? Okay, can you look around the room and spot any lines that don't intersect but are not in the same plane? Can you find some examples? So, if I use my arms here, okay, as lines, okay, and if my arms are like this, roughly, we would say that those two lines are parallel. Okay? I'm just kind of estimating here, but wouldn't you say that these two lines would be in the same plane? There would be a plane that would go this way, okay, that would contain both of those lines, and these lines aren't going to intersect. Okay? That would be parallel. Okay? If I looked at the wall, okay, right up here, I can see that I have this line and I have this line right there. Those two lines are in the same plane. They're in that wall and they do not intersect. Okay? So what would it look like for lines to not be in the same plane and not intersect? Let's go back to my arms. Okay? If this is a line and if this is a line, skew lines might look something like this. Okay? Can you see how these two lines would not be intersecting, but there's no way that they'd be in the same plane? There's no plane that would contain both of them. So skew lines might look like this. They might look like that. Okay. Maybe like this. All right, hopefully that got a laugh. If I just use, here they are, a couple pens. Okay. Parallel. Parallel. Skew. Skew. What would this look like if we were to draw a picture of it? Let's draw a sketch in here to help us imagine what this would look like. And I think maybe the best way to draw this would be to, let's draw a cube. So there's a quick sketch of a cube. Okay, can I draw two lines that are on this cube that do not intersect but are not in the same plane? So there's one. This is on the face of the cube closest to us. Okay, it seems to be running left and right. Okay, and how about I draw one right here? Okay, that's on this face over there. The line is running up and down. Are those two lines going to intersect? No, they're not. This one on the face closest to, that's closer to us. This line back there is a little bit further back and going vertically. Okay, those two lines would be skew lines. Parallel planes. This one's pretty simple. Two planes are going to be parallel if and only if they do not intersect. There's not much more than that. Let's write that in there. You know, at the start of the year, I had you guys playing around with note cards and treating them like planes. So what do parallel planes look like? Something like this. Two planes that are not going to intersect. Let's draw a sketch of that as well. There's my first plane. Okay, and there's my second plane. Okay, one is directly over the top of the other. They're not going to intersect. Those planes are parallel. So let's check in. Let's make sure that we understand some different definitions that we have so far. I'd like you to flip to the first example in our notes. And we'll head back to vocab a little bit later. But let's just check in on what we've covered so far, combining some of our terms from previous chapters and then from this chapter. If you look at this diagram, I like using this diagram because it talks about, we could look at a lot of these different words and make sure that we gain a good understanding. But there's some issues with the diagram. If you notice here, there's 2 points that are the point A. So let's change this to, what letter should that be? Should we call this H? And this one's, that vertex is actually missing a name for that point. Let's call that G. All right, now that we've fixed that, think of each segment in this right prism as a part of a parallel line. Name all the lines or planes that fit this description. So lines parallel to line AF. I want to name every line that's parallel to AF. Okay. Here's line AF. What lines are parallel to that? Okay. So double checking that definition. I already had you look it up again. Okay. Two lines are parallel if and only if they do not intersect and are in the same plane. So what would be another line that's in the same plane as AF that's not going to intersect it? Okay. Isn't EJ in the same plane as AF? Okay, they will not intersect. Those are parallel. Line EJ. Okay, are there any others? Okay. Take a look at this line back here, line BG. Can you see that they're in the same plane? Kind of, if this was almost like a house, it'd be the roof on the other side. That those two are both in this plane. They're not going to intersect. They're parallel. So we got line BG. Is that it? Okay. This is where sometimes students get a little goofed up here. How about this line DI? is that line parallel to line AF? Well, they're not going to intersect, but are they in the same plane? This is the part that throws students off. Just because we can't see the plane doesn't mean that there wouldn't be a plane that would go through both of those. If I were to slice through this, okay, couldn't I slice through it in a way that I would cut it and I could see that those two would be on the same plane? Just go ahead and slice right through that. Yeah, I could, couldn't I? In fact, if I just draw this right there, okay, they're in that plane that goes diagonally through this solid. Okay, so DI would be parallel, and so would CH. All right, now we're going to go to skew. Skew to line AF. So again, looking for lines that don't intersect, but this time are not in the same plane. Okay, I can spot a bunch, ED. Okay, that's going to come up, okay, kind of vertically, a little bit at a diagonal though. It's not going to intersect AF, and they are not in the same plane. How about IJ? Line IJ, not going to intersect AF, not in the same plane. Okay, any others? Yeah, let's keep going. CB. Over here, HG. Okay, is that all? No, there's still more. Okay, take a look at CD. CD is running across the bottom of this. Okay, AF is running up here this way. They are not in the same plane. And we could say the same thing about HI. All right, now we're looking for lines perpendicular to line AF. Kind of breeze through this up here pretty quickly. This is our right prism. Okay? In a right prism, all these what we call lateral faces. So the pentagons are the bases. These lateral faces are all rectangles. And rectangles have right angles. So I know some of you might be thinking, I don't see any right angle symbols. Well, because I told you it's a right prism, we do have right angles. So what are lines that are perpendicular to AF? AE, FJ, couple more. BA on the back side would form a right angle. It's kind of tough for us to see that, but it would. And same with GF. Good. All right, last one with this diagram. Okay, let's name the planes that are parallel to plane FGH. Remember how we name planes? 3 letters, non-collinear points. Okay, so plane FGH would be this plane on the back. That one right there. Okay, what planes are parallel to it? Okay, definition of parallel again. 2 planes are parallel if and only if they don't intersect. Okay, we should be able to spot that this plane would be parallel to that one. How do we name this? A bunch of different ways. Just pick 3 points that are on that plane that are not collinear. Let's call it plane A, B, C. Okay. Still talking about lines here. Two postulates that I think will make sense to you after we describe them here. Parallel postulate. If there is a line and a point not on the line, then, okay, let's pause. Let's make sure that we understand what this looks like. If there is a line and a point not on the line. There's a line. There's a point not on the line. Okay. Then there is blank line through the point parallel to the given line. How many lines can we draw through that point that are parallel to this given line, the line that we're starting with? How many can I draw through that point that are parallel to that line? Exactly 1. Only one line parallel to that line through that point. Perpendicular postulate. If there is a line and a point not on the line. Well, that sounds familiar. If there is a line and a point not on the line, then there is blank line through the point perpendicular to the given line. How many lines can I draw through this point that are perpendicular to that line? Exactly 1. Now, I'm sure that you guys probably believe that already to be true, but I just want to demonstrate that just in another spot here. I'm going to go into GeoGebra quick. There's a line. There's a point not on that line. I know I have a parallel tool in here somewhere. Right there, parallel line tool. And if I select it, notice what the directions say down here. Select point and parallel line. Okay. So if I select the point and the line, okay, how many lines did it just draw there? 1. Only 1. Exactly 1. Okay. If I find my perpendicular tool, select point and perpendicular line. If I pick the point and the line, how many perpendicular lines did it draw? Just 1. All right, so okay, take a look at this diagram. Name a pair of parallel lines. Okay, which lines are parallel, and how do I know that? Well, hopefully you noticed those extra set of arrows right there. We've talked about that before, that's a marking to show that these two lines are parallel. Line AB, parallel symbol, 2 vertical lines. It's parallel to CD. Name a pair of perpendicular lines. What are we looking for there? Definition of perpendicular lines again would be 2 lines are perpendicular if and only if they intersect to form a right angle. Where do we see the right angle? There. So which 2 lines are perpendicular? AB and AC. Perpendicular symbol. All right, letter C. Is line AB perpendicular to line BC? I'm guessing everybody's thinking right away, they're saying no. I would agree. So the better question is not just are they perpendicular? The answer to that is no, but why? No, because what? How do you know that those 2 lines aren't perpendicular? Don't tell me it's not. It's because they don't look like they are. I agree that they don't look like they're perpendicular, but it doesn't look like it is not a good reason. That's not something we use in geometry. Oh, it doesn't look like a right angle. Okay. I know we've talked about this before, but that gets tricky. Right? Are those lines perpendicular? Well, they look like it, but maybe they are, maybe they aren't. Okay. We cannot say they're perpendicular or not perpendicular just because of the way it appears to be. There has to be a reason in there. Okay. So then some of you are probably thinking, well, there's no right angle symbol. I only know it's a right angle if there's a right angle symbol. I understand where you're coming from. But isn't it possible for something to be a right angle without it having been marked in there? And I know we haven't talked about this yet. Okay, this will be a conversation later this year. Okay, that angle right there, it's a right angle. I know that even though it's not marked as a right angle. Okay. Has to deal with some other properties of quadrilaterals that we haven't learned yet. So there are times where something's a right angle without a right angle symbol in there. So again, I agree, they're not perpendicular, but can you tell me why? How do you know they're not perpendicular? Let me take a drink here of water. I'll let you think about that some more. How do I not know that those are perpendicular? I wonder. What's this perpendicular postulate say again? If there is a line and a point not on the line, then there's exactly one line through the point perpendicular to the given line, right? There's line AB. There's a point C. How many lines can I draw through the point C that are perpendicular to AB? One. Exactly one, right? Okay. So there's only one line through C perpendicular to AB. And guess what? We've already said that, haven't we? We already have that. AC is perpendicular to AB. That's the only line that can go through C that's perpendicular to AB. That is solid reasoning. It's not because it doesn't look like it. It's not because there's not a right angle symbol, but because we know that there's exactly one line through C perpendicular to AB, we already have that one. No, because by the perpendicular postulate, there is only one line through C that is perpendicular to line AB. AC is perpendicular to AB. So BC cannot be perpendicular to AB. There we go. All right, we're going to wrap up our lesson today talking about some pairs of angles, some special names that we haven't talked about. It's going to be important that we know the names of these angles because we're going to be communicating about them. So if we're communicating about them, we need to know their names. So first off, let's talk about a transversal. If I have two lines, and I have a line that intersects those two lines, that line, the red one in this case, is called a transversal. So a transversal is a line that intersects two other lines. And we can see when we have a transversal, it creates a bunch of angles here. There are 8 of them. There's 4 up here and 4 up there. Okay? And what we've looked at in the past, okay, we looked at that situation. What happens when we have 2 lines that cross? But now we're going to put in another one in there. Okay? Again, going back to this, we know we have vertical angles. We know that relationship. We know that we have linear pair. We know that relationship. But what are the relationships, okay, between the angles up here and the angles down there? Okay? So we have some special names for those relationships. Corresponding angles. Okay? If something's corresponding to something else, they kind of match up in a way, right? And when we look at this situation, okay, let's again draw 2 lines. And a transversal. Our corresponding angles would be angles that are in the same position. Okay, I'm not going to be writing these as biconditional. We're not going to be using the definition of corresponding angles as any reasons in proof, so I'm going to be a little bit more informal in this. Corresponding angles are angles that are in the same position. Okay. So if I look at this diagram over here, and I pick this angle, I'm just shaded in green. Okay. Which angle down at this intersection is in the same position as that green angle up there? Well, I would describe this as kind of being the top left angle. What's the top left angle down here? It's this one. Okay. They're in the same position. Top left, top left. Or if you want to, prefer like northwest, northwest. Okay. When we look at that, we end up with several pairs of corresponding angles. Wouldn't this angle correspond with that one? Wouldn't this angle right there correspond with that one? And then we'd have the last pair of corresponding angles being right there. So corresponding angles, I want you to think same position. Alternate interior angles. All right, let's break that down. If something is alternating, okay, what does that mean? Okay, what does that word alternate mean? Well, to alternate means to kind of go on, kind of like back and forth, right? Back and forth on different sides of something. Okay, interior, we know that means inside. Okay, so we're talking about the angles that are inside these 2 blue lines. Okay, so there's 4 angles inside the blue lines. And we're talking about angles that are alternating or on the opposite sides. So this angle right here, okay, that would be one of them. What is another angle that is inside the blue lines but alternate sides of the transversal? That angle right there. Okay, so again, alternate interior angles, I want you to think opposite inside. Okay, those 2 green angles are alternate interior angles. We would have another pair of alternate interior angles, this one was that one. So corresponding, same position, alternate interior, opposite and on the inside, opposite sides of the transversal inside the 2 lines. Okay, let's continue. Alternate exterior. And you're probably putting this together, thinking about alternate interior. Alternate interior was opposite inside. Alternate exterior is going to be opposite outside. So think opposite outside. So let's pick one angle outside the blue lines. Let me pick this one. What is another angle that is outside the blue lines but on the opposite, the alternate side of the transversal? That one. Those two are alternate exterior angles. We'd have another pair of alternate exterior angles with those two. Last one, consecutive interior. Okay, we already know what that word interior means. It means it's inside the two lines, or two blue lines. Consecutive interior. Well, we've already talked about alternate interior being on the opposite sides. Consecutive interior would be on the same side. Consecutive means back to back, right next to each other. Okay. This angle and this angle are consecutive interior. I want you to think same side of the transversal, inside. Consecutive interior angles. Okay. These two angles over here would be another pair of consecutive interior angles. Okay. So it's important that we know these terms, okay, that we're able to communicate about the pair of angles that we're looking at. Okay. So today we're just working on the names. And again, it's important because tomorrow, okay, we're going to look at the relationship between them. What do we know about those angles under certain circumstances? Okay. So let's just double check that we've got this. Identify all corresponding angles. Okay, let's pick angle 1. Angle 1 and what other angle are corresponding? What else is in the same position? 1 is in the same position as 5. How about 2? What angle's corresponding with 2? What's the angles in the same position? Top right. Come down to the other intersection. Top right. 2 and 6. Okay, let's go to angle 3. Angle 3 is in the bottom right of this intersection. What's in the bottom right of this intersection? 7. 3 and 7 are corresponding. Okay. And our last pair would be 4 and 8. Okay. Those are our corresponding angles. Next type. Identify all alternate interior angles. Alternate, opposite sides of the transversal. Interior, inside the two lines. Identify all alternate interior angles. Let's pick 4. Okay. What's on the opposite side of the transversal and inside these two lines? 4 and 6. Our other pair of alternate interior angles would be 3 and 5. C, identify all alternate exterior angles. So now we're going outside of these two lines, such as angle 1. Alternate exterior, opposite side of the transversal, also outside, 1 and 7. And then we would have 2 and 8. Last pair, consecutive interior, same side inside, 4 with 5. And then 3 and 6. All right, let's just double check. Okay. Take a look at angles 3 and 4. Can we identify, can we name what type of pair of angles those are? We were just working on, here's the name, find the angles. How about this? Here's the angles, find the name. What is that pair of angles called? There's my two lines. This red one's my transversal, so I notice they're on the same side of the transversal. They're inside these two lines. These would be consecutive interior angles. Next diagram, which one's my transversal? One's my transversal, isn't it? Angle 1 and 2. They're on opposite sides of the transversal. They are alternate angles. Are they inside these two other lines or outside of them? They are outside. These would be alternate exterior angles. All right, there we have it. Okay, day 1, one of my favorite chapters. Like I said, tomorrow we're going to start to look at some of the relationships between these special types of angles that are formed with two lines in a transversal. Thanks for tuning in. We'll see you later.